number, the first question in 7.07 Brain Honey Algebra 1 asks, is this a perfect square trinomial? And the answers possible are sometimes, always, and never. Well, to find this, it's best to just take these two terms and multiply them together using the FOIL method. First, outside, inside, last. So if I multiply a times b first, then a times, a times a, then a times b, then b times a, then b times b, should come up with an answer here. So a times a is a squared. A times negative b, I should point that out, that's a negative b, is a negative ab. And then b times a, this one times this one, b times a, that's a positive b times a positive a, is a plus ab. And then a b times a negative b, this one right here, b times negative b, is a negative b squared. So as you can see, this term and this term, they go away. They add up to 0. So you're left with a squared and a b squared, and that's a negative b squared, so you have to do a negative sign in between. There's a squared minus b squared. So you might ask, well, are there any circumstances that this would be true, where it would be a perfect square trinomial? So somebody asks me, well, what if b were a -1? Would that change things? Would that make it so it's a perfect square trinomial? Well, what you got to remember is you got to put that number in two different places here. So let's try it. Let's put in -1 for b. So if we have a plus a -1 times a minus a -1. Well, right off the bat, let's make this a little simpler. First, a minus a -1, let's make that a simpler problem. A minus a -1 is the same thing as a plus a -1. And then over here, this part, a plus a -1 is the exact same thing as a minus 1. So let's rewrite it. A minus 1, and I'm just going to do this just for clarity, a plus 1. Well, a minus 1, a plus 1, 1 is a perfect square. You know, this is going to turn out to be the same thing as we had before. Let's multiply it out. A times a is a squared. -1 times a is negative a, or -1a. And then, oops, hold on a second. I skipped a step here. A times a is a squared. A times that is 1a. That's a positive 1a, so plus a. And then the next one is -1 times a. That's going to be a negative a. And then a -1 times a positive 1 is going to be a -1. So these two things cancel each other out. You're left with a squared minus 1, which is the difference of squares once again. So I don't think there's anything you can find for b that's going to change that fact. It's going to be a difference of squares each and every time. So the answer to the question is the product of those two things, these two things, is a perfect square trinomial. It says always, sometimes, and never. And the answer for this, in this case, is going to be never. Well, I hope that helps. I'll see you next time.